Hi guys, this is Mrs. Gravakis. Today I'll be chatting with you about Unit 5, Lesson 3, which talks about medians and altitudes in triangles. So when we are working with medians and altitudes, we have specific vocabulary. Medians and altitudes are related to the points of concurrency. Points of concurrency, if you remember from Lesson 2, is when all three lines end up meeting at a certain point, and these points have names. So for the medians connect the vertex to the midpoint of the opposite side. And what happens is when these medians meet, they end up cutting each of the other medians into a 1/3, 2/3 relationship. So where all of these medians meet is called the centroid. So the point of intersection of all three of these lines is called the centroid. So 2/3 rule applies to all medians in the triangle. So for example, when you're looking at triangle ABC, if you're looking at G right here, these are all going from the vertex to the midpoint of the other side. So F would be considered a midpoint, E would be considered a midpoint, and D would be considered a midpoint. So that means BF and CE are the same length, CE, AE are the same length, and A to D and B to D are the same length. So when you're working with a median, they connect from the corner to the midpoint of the other side. So these are all medians. We just talked about when all the medians meet, what is that point called? So number 1 is asking what G is called in the triangle. G is called the centroid. So now this is where we're using our 2/3, 1/3 rule. So we are given AF, and AF is 12. So from A to F is 12. So this is the 1/3 part, and this is the 2/3 part. So from F to G is the 1/3 part, and from G to A is the 2/3 part. So we have to think about how to cut 12 into thirds. So think about how you have 12 divided by 3. That equals 4. So from A to G is the bigger part. So what we would do is we would take 4 and multiply it by 2. So the measure from A to G would be 8. So that means the measure from G to F would be 4. And just to make sure, if we add those together, does that equal 12? 8 plus 4 does equal 12. So that does go back to what we were originally given, that AF is 12. What happens if you're given a part of it? So for example, for number 3, you're given that BG is equal to 10. So from B to G is only part of this line. So this is the 2/3 line, part of the line. And this is the 1/3 part of the line. So what you can do is, since you're given the 2/3 part of the line, you can take that number and divide it by 2. So in number 2, we were given the entire line, so we divided it by 3. For BG, we were given the 2/3 part of the line, so we're going to divide that by 2. So that means that the 1/3 part of the line is 5, and that's from G to E. So the measure from G to E is going to be 5. So then it's asking for B to E, meaning the whole thing. So the 2/3 part's 10, the 1/3 part is 5. So that means the entire thing is equal to 15. So the last bit is the information about A to C. A to C, wait a second, A to C is the side length. So from A to C, we know that this is 13. Well, medians are made from connecting the vertex to the midpoint of the other side. So that means that E is in the exact center, the midpoint. So if the entire thing from A to C is 13, then we would have to cut 13 in half to get from E to C. So that just means that the measure of EC is half of 13, which translates to 6.5. All right, so the two tasks that you will be asked to remember and regurgitate on an assessment would be to identify if something is or is not a centroid, as well as applying this 2/3, 1/3 rule. For the altitudes, what comes in mind when you think of an altitude? Maybe a mountain, right? How high something is off of the ground, like a plane. So what happens is when we're thinking about an altitude, that brings back this idea of something being perpendicular. So an altitude specifically in a triangle is when we connect the vertex straight down to the opposite side. So you have this right angle going on here. This one is also a right angle. This is also a right angle. So the point where these all meet also has a name. It's called the orthocenter. So now you have to be careful with this. In lesson 2, you will learn or have learned that we have a perpendicular bisector as well, and those meet at what we call a circumcenter. Perpendicular bisectors are different than altitudes. Please be careful. Do not confuse these two things. Perpendicular bisectors do two things. They're perpendicular and they bisect. Altitudes only do one thing. They are perpendicular. So if you do not see the tick marks that tell you that that gets bisected, the sides get bisected, then it is an altitude. It is not a perpendicular bisector. So be careful about confusing those two things. So altitudes. We learned that, or will learn that, perpendicular bisectors met in specific locations depending upon the type of triangle. So just like the circumcenter, the orthocenter is actually located on specific locations depending upon the triangle. So for acute triangles, it's on the inside, just like the picture above. Up here, it's on the inside of the acute triangle. If it's a right triangle, it's actually on the vertex of the right angle. So the corner that has the right angle is the orthocenter of the right triangle. And when you're dealing with an obtuse triangle, you are dealing with an orthocenter that is outside of the triangle, specifically behind the obtuse angle of the triangle. Okay, so what would we ask of you? Make sure that you can figure out if something is an orthocenter based off of a picture. The other thing that we could ask you is finding an orthocenter. And we're never going to ask you to find an orthocenter, at least on an assessment, that it is not a right triangle. So really, the goal here is to sketch this triangle and figure out the orthocenter. And from the last slide, we said that the orthocenter is the right angle, or the vertice that has the right angle. So we have 0, -2. We have 4, -2. And we have 0, 8. So we're looking at this kind of a triangle. Again, the orthocenter specifically is the right angle of the triangle. So this right here is the right angle of the triangle, which is associated with A. So that means the orthocenter is at 0, -2.